What is the rule saying?
High, low.
Low!
Cosine of
Cosine theta.
D high.
D high.
cosine
Minus.
Minus.
High.
High.
sine
D low. Over. Low squared. Cosine squared theta or cosine of theta in parentheses squared. Either way is correct. Either way is correct. You don't have to erase it. Okay? So, let's see. Can we do any simplifying here? What's cosine times cosine? Okay, so we got cosine squared theta. Sine times negative sine is negative sine squared times the negative makes it plus sine squared theta over cosine squared theta. We can cancel these out, right? We cancel these out and it's just sine squared? No? We can't cancel those out? Why not?
Because they're not.
Very good. It's not common factors, right? Common terms, so we can't cancel out common terms. Okay, but is this a particular identity that we should know from pre-cal?
1.
That is equal to 1, right? Over cosine squared theta. And we should know that 1 over cosine is what? So we know that 1 over cosine, right, is equal to the one that starts with the other letter, which is secant, right? Why couldn't have these wonderful mathematicians just put it with the same letter, right? Like 1 over cosine, make it cosecant, right? I mean, you're inventing this stuff, just have it make sense, right? No, they have to be mean and then switch up the letter, right? Like, let's just be evil and
Make me more dyslexic.
yeah, that's for sure, right? But anyways, so if 1 over cosine is secant, then 1 over cosine squared is what? Secant squared theta. So now that we know how to find the derivative of tangent, now when I ask you for the derivative of tangent, I want you to just say what? Secant squared theta. We need to memorize it. Okay? Cool? Let's do cotangent now. So cotangent is what? Cosine over sine. Well, what do you know? We got another quotient. What do you think we got to do? Quotient rule. Let's do it. Low. So I'll say the words and you tell me what to write. So low. D high. Minus. High. D low. Over low squared. Sine squared theta. Okay? What do I end up with? Negative sine squared theta minus cosine squared theta over sine squared theta. Oh man. If it was only a plus and a plus. Take out a negative? You guys are good. So if I take out a negative 1, that leaves me with sine squared plus cosine squared. And we know that that's equal to what? 1 times negative 1?
Negative 1.
Over
Sine squared theta.
sine squared theta. So do we know that identity? What's 1 over sine? There it is, the one with the other letter. So mean. Cosecant. So 1 over sine squared should be what? Negative cosecant squared theta. That's another derivative that I need to memorize. The derivative of cotangent, negative cosecant squared theta. The derivative of tangent, secant squared theta. You have to know them, okay? Because now in the problems we're going to have these trig functions and you need to know their derivatives. We're not just going to have sine and cosine anymore. Cool? Alright, what was the derivative of cosine again? Negative sine. And what was the derivative of cotangent? Negative cosecant. So anytime you're finding the derivative of a trig function that starts with a c, that derivative answer should start with a what? With a negative, okay? So that's something to keep in mind also. Right? If I had a derivative of cotangent, negative, right? The derivative of cosine, negative sine, so you need to have those negatives there. When we get the derivative of cosecant, what is it going to start off with? A negative. Cool? Alright, let's try these last two here. What's the what can I rewrite secant as? 1 over cosine. Alright, so let's apply the quotient rule. Ready? So, low, d high, 0. Minus high, d low, over low squared. Okay? So anything times 0 is what? That goes away. Negative 1 times negative sine, that gives us positive sine theta over cosine squared theta. And how could I rewrite that? Tangent of theta times secant of theta? How did you do that?
You just take out, well, you break it.
Separate them? So I could do this, like 1 over cosine times sine over cosine? Yeah? Are these two the same things? Yeah, 1 times sine is sine, cosine times cosine is cosine squared. I just separated it so I could figure out which trig function they're equivalent to, right? So we know 1 over cosine is what? Secant, that's what we started with. And sine over cosine, we did it up here, was what? Not secant squared, tangent. The derivative of tangent is secant squared. Did we find the derivative of secant? Yeah. What's the derivative of secant? Secant theta, tangent theta. What do you think the derivative of cosecant is going to be? Negative? Cosecant theta? Times cotangent? You think?
I think it'll be
negative.
Cosecant, cotangent? With a negative?
Yes,
Why with a negative?
because
Because of the C.
is negative.
Very good. The derivative of what starts with a C, right? Alright, so let's try it. Let's see if our theory is correct. Okay, let's prove it to the world. So we end up with 1 over what here? Sine. Okay, so let's do the quotient rule. So we want the derivative of this. So it's going to be low d high minus high d low over low squared. Anything times 0 is? So we end up with negative cosine theta over sine squared theta. How can I separate that? Negative 1 over sine times cosine over sine, okay? So what's negative 1 over sine? Negative cosecant. Ooh, we're starting off correct. And what's cosine over sine? Cotangent. Ooh, you guys were right. God, you guys are super geniuses. You're like Sir Isaac Newton, discovering the quotient rule and publishing it.
Is there going to be a shortcut to this one?
Is there going to be a shortcut? Well, just memorize it.
So there is going to be. Okay, not like, yeah, but
Like these are just like you learned the derivative of sine was cosine, the derivative of cosine was negative sine. You need to be able to do these just as fast.
okay.
So if I say the derivative of tangent, you tell me secant squared. The derivative of cotangent, negative cosecant squared. The
Okay.
derivative of secant, secant tangent. The derivative of cosecant, cosecant cotangent, negative cosecant cotangent. So they're pretty easy because you can remember that they start with the same thing, right? And then you can relate it to the other one that was positive, which was tangent, right? This one's negative cosecant, so the cotangent was also. I don't know, for some reason they're really easy to memorize and a lot of the kids get them really quick. Good. Can we keep going?
No.
No? You've had enough? We could do one more page.
Okay, well, let's do the homework.
Let's keep going. We don't leave till 12:07. 11:30. 30 minutes.
Why is this class always going so fast?
Goes by fast?
What's the
That's what I say, man. We're having like these wonderful moments.
Because you guys know what you're doing.
You just fly by. Alright, Anias, you ready? So let's say the quotient rule so we can get pumped up, alright? But I want to feel it. I don't want to just hear it. I
Guys,
want to
let's
feel it like
Let's
Axel
feel
said.
it.
Ready?
Let's feel it, guys. Let's
Here
feel
we
it.
go.
Low.
High. Minus. High. Low. Over.
Good. You got it? So you can watch the video and make fun of me on YouTube.
Oh, that's gonna be glorious. Oh, thank goodness.
Good?
So you don't waste your mind. That's
Alright, let's try this one. What do they want here? Slope of the normal line. Okay, what do I have to do to get the slope of the normal line? First I need to get what? Do I need the equation of the tangent line? No. I just need the slope of the tangent line. And what gives me the slope of the tangent line? The derivative, right? So we need to find the slope of the tangent line. In order to find that, I first need my derivative. Right? And to get my derivative of this function, what do I need to use? Quotient. So let's do it. So, low, d high, 3 minus high, d low, over low squared. Okay. Let's write it out nice and pretty. What do we end up with? 3 cosine theta plus 3 theta sine theta over cosine theta squared. Okay? What are we going to plug in? Why do we write it different? Because we can. What are we plugging in? Pi. So let's plug it in. So 3 times cosine of pi plus 3 times pi times sine of pi over, this is why I wrote it different. Because I want you to figure out what cosine of pi is and then square that right. Okay, so you don't get confused. Good? So we need the coordinate at pi, so what would the coordinate at pi be? Let me draw my unit circle, like on the midterm.
Was
Yeah,
that you?
yeah.
Yes, I saw it.
So what's the coordinate at pi?
that was me.
Negative 1, 0, so this is cosine and this is sine, right? So let's replace it. So this is going to be a negative 1 right here. This is going to be a 0, right? And this is going to be a negative 1. Negative 1 times 3? So negative 3 plus, what do I get over here? 0 divided by negative 1 squared? 1, so that gives me negative 3. Is that what I want?
No.
No, good, you remember. We don't want the slope of the tangent, we want the slope of the normal line, which is the sum of the slope of the tangent line.
Sorry, it's because you just do the like thingy, and that's all I remember. I remember the actual words.
Yes.
I'm like, 1 over 2.
So what would it be? 1
Yes.
over 3. Why?
Sorry.
Because it's opposite reciprocal because they are what? Perpendicular to each other. Good? You got it? You don't need any more examples?
No.
Ah,
No, we're good.
Are you sure?
let's go.
You ready for the assignment?
Yeah.
Yes.
No? You want me to do them?
No.
I can skip them if you want because you guys are really advanced.
Yes.
I know.
Do the fourth one only?
Over here.
May the fourth be with you?
Do the one that's already a freshman.
Do them all? I'll do them all for you, Caitlin, okay?
I'm sorry.
I just like to make you feel like I'm not going to do them, but I am going to do them anyway.
Yes.
I was gonna make him sorry.
Alright, ready, Gabriel?
Yes.
Okay, here we go. So look at this bad boy right here. It's a fraction. I gotta use quotient rule if I want its derivative. Let's do it. They're all fractions? Oh, what do you know?
I mean, I guess you have to use.
I guess, right? Okay.
So
what would we do? Low, come on, do it fast. X plus 2 times d high
2x minus 2.
minus high d low over low squared. Most of the time you're not going to actually expand that in the bottom, so you just write it out like that. Sometimes you will go further, you'll see in some of these examples, but sometimes you won't. Alright, so let's do it. Let's expand. All this is algebra now. We already did all the calculus. Now this is back to algebra 1 and algebra 2. So x times 2x,
2x squared.
2x squared, minus 2x, plus 4x. So that's just plus 2x. Can I skip the step where I write both of them? No? Yes? And then it'll be minus what? Minus 4? I like to skip that step.